So from today, we will start the second part of our syllabus, which is about the alternating currents and voltages. Okay. So far, whatever we have studied, this was about DC current and voltages, which do not change with time. Obviously, like if you say is a charging capacitor or an inductor, yes, the current and voltage just change with time, but rather better way to put it that our voltage and current sources, they are not fixed, they vary with time, but they follow a definite pattern. It's not random. Okay. AC sources can be of many types. The most common one is the sinusoidal. Sorry, it is uniform magnitude. It is not showing this. Right. If this is my peak voltage, Vm, then the expression for a sinusoidal voltage is Vt equal to Vm. Sine or cos, both are okay, both are okay. Omega t plus phi. Omega equal to 2 pi f is called the angular frequency, whose units are radians per second. Phi is the phase, and Vm is the amplitude. Obviously, the maximum value a sine or a cos function can take is 1. So the maximum possible value of Vt is Vm, right? So we start with some definitions regarding the alternating currents and voltages. First one is waveform. What is a waveform? Abhi Roy is in your class? CR? Abhi Roy 2056 in this class?
Yes,
sir.
sir. Yes, sir.
A waveform is Kumar Mauritius is from our class. Is a graph in which instantaneous value of a quantity, usually voltage or current in our case, is plotted respect to time. Okay. What is a cycle? Cycle is one complete set of positive and negative terms. So obviously this is one cycle from here to here. Frequency. What is frequency? Number of cycles per second. Right? This is known. Time period. Time taken for one cycle, that is 1 by f, if this is f frequency is f. Amplitude, the maximum possible value the waveform can have. Okay, phase. It is the time elapsed since the waveform has last passed the 0 mark. Okay. Obviously, this has a phase of 0. This waveform, it has a phase of 0. Fine, so it's fine.
Sir, could you please repeat once again after time period?
Yes,
The voice had been breaking.
the next is phase. Phase is the time it has passed since the amplitude has passed the 0 path of difference. So this is a phase. The phase here is 0. Let us say another one whose phase is 90 degree. So it will fall from a graph like this.
रे प्रभात रे गिरे भुइया में रे
Who is it? Please mute your microphone.
सब छोटा होते हैं सब बड़का बड़का में रे प्रभात छोड़ दे रे प्रभात छोड़ दे सब हम छोटा बड़का बड़का हम सब है
Okay. So this has a phase of, this leads the black waveform by 90 degrees, isn't it? The green waveform, it leads the black waveform with a phase angle of 90 degrees. Do you agree? Another one, the blue waveform, this has a Vm sine omega t minus 90. So the green waveform, it leads black by 90 degree. The blue one lags black by 90 degree and lags green by 1. Can we say this? Can we say this?
Yes, sir.
And wave, and since you are in electronics, phase, it might not seem to be very relevant now, but as you move ahead of not just this course, but your course of electronics and communication engineering, you will see that phase plays a very, very crucial part of a waveform. And often we utilize the phase of a waveform to transmit information. Okay, the information we are transmitting, we can often hide it in the phase of the waveform. So phase is something that is very important. We utilize this phase in many ways. May not be that much in this course, but in subsequent subjects. Okay. Average value of a waveform. If I have a waveform, say Vt, whose time period is t, then V average, often given by a bar over V. That is simply this. So if Vt is A naught sine 2 pi ft, what is this? Can you calculate what is the value of V average t?
So what is VT?
Even here, this one.
So A naught sine, what's in the bracket?
2 pi ft, 2 pi ft. Okay, where f equal to 1 by 2. So what will be v bar t? 1 by t, 0 to t, a naught sine 2 pi small t by capital T dt. A naught is a constant, I can take it out of the integral. Dt. Right? So this would be a naught t gets cancelled. Cos 0 minus cos 2 pi. Its value is 1, its value is also even 1. So this one is 0. Okay. So V naught V bar t is this is 0, but note that this is expected because the waveform is like this, and you see that the area under this curve is same for the here and here. So obviously V bar t equal to 0 is an expected value. Have you studied rectified electronics? In the basic electronics course, have you studied rectified? In basic, has rectifiers been covered in basic electronics course?
Yes, sir.
Yes. So obviously, sir has taught shown you full wave rectifier where the output looks like this. Yes. And there, if you calculate, you will find that beta is not 0. Okay. Because now every part of the wave is above the x-axis. Nothing is below the x-axis. Right. So this is the average value of a sinusoidal wave. The next part is root mean square. RMS value. RMS value is defined as VRMS, that is square root of 1 by t, 0 to t, v square t. Okay. Please find the RMS value, Vt equal to a naught sine omega t, sine 2 pi t by t. And the RMS value of this electron. Rohit Modak in this class, 2021. Is Rohit?
Yes, sir.
Please find VRMS. ক্লাসে আছি বলো কি হলো? হ্যাঁ আচ্ছা আচ্ছা ঠিক আছে করো। ও, ঠিক আছে সরি did you find what would be the RMS? Just put simply use this formula 1 by t. This would be a square sine square.
It's
A
A
naught by
naught
root
by
2.
root 2.
Yes,
sir.
yes, of course. A naught by root. Very good. That's the right answer. A naught I can take out of the integral because it will not change. Now I use the formula that cos 2 theta equal to 1 minus 2 sin square theta. Is that right? So this would be A naught 1 minus t 0 to t dt minus 0 to t cos of 4 pi t by t dt. Right? This 2 is coming here because this is 2 sin square theta. Now, if you do this integral, you will find this is 0 and this is t. So I get A naught 1 by 2. Okay, all of you have got this. Now, two important definitions, which is very important for MCQ type exams. First one is called the peak factor. Peak factor is defined as maximum value by RMS value, and second one is form factor, which is defined as RMS value by average value. So what is the peak factor for the wave we just discussed?
Root 2.
Yes, obviously. And the form factor is infinite because RMS value is 0. Sorry, not RMS value, sorry, average value. Not RMS. Form factor is infinite because average value. So this is the basic of an AC wave. However, often we prefer to express our waveform in phasor form. Okay. So what is the phasor form? Suppose my waveform is like this. Vt equal to Vm cos omega t plus phi. Okay. So we can write it as root 2 Vm by root 2 cos of omega t plus phi. I am doing this because this is the RMS value. Okay. Can we write it in this way? Oh, just not write G for the time. Can we write it in this way? I equal to, you know, and real part of this means if I have a complex number z equal to x plus iy, then real part of z would be x and the imaginary part of z would be y. Can we write this in this form?
Didn't get, sir.
Yeah. So can we write it in this way?
So how this?
Okay, how? Suppose I have a complex number z, which is x plus iy. Right? Complex numbers are studied in maths, I hope.
Yes, sir.
Okay. So we can write a complex number in this way. Z equal to x plus iy. Okay. It is possible to express a complex number also in this form, or where okay. Is it okay? Do you know this form as well?
Yes, sir.
Agreed? We can write it in this form. Now, do you know De Moivre's theorem that e to the power of I theta, that is cos theta plus I sin theta? Are you aware of this equation? It's called De Moivre's theorem. You must have studied this.
Yes, sir.
So, can we write it in this way? This RE simply means RE of Z is simply X. The real, if I this RE function just gives out the real part of the complex number. There can be an IEM function as well that would give out the. So we can write it in this way. Is it okay? Is it okay?
Yes, sir.
Right. Now, what we have in our hands is Vt equal to Vm cos of omega t. Sorry. Cos of omega t plus 1. Is it okay to write it in this way? Rather, is it okay to write it in this way? Yes or no? Can I write this equation in this form?
Yes, sir.
Okay.
Yes, sir.
Can I write it in this way? Vm is a real number. Vm cannot be imaginary. Okay. This part, whatever is inside this RE, this is the phasor representation of the signal. This √2 because we want to express in terms of the RMS value. Okay, that is why this √2. Okay. So if I have the phasor representation of a signal, we can retrieve the signal by simply taking √2 times the real value of the phasor. Please note that the phasor and the signal, they are not the same thing. The signal is almost like is a real number. phasor is almost always a complex number. So the signal and the phasor, they are not the same thing. But we often prefer to represent a signal by the corresponding phasor notation because it gives us some advantages, because it helps us to make our own calculations easier. Is it okay? Is it okay?
Sir, Yes, please sir. repeat.
Sure. This term, which I have circled, this is the phasor representation of this signal dt. Okay. The phasor and the signal are not the same thing. Why? The signal is always real. This is always real. This is not imaginary. Everything in this equation is real. However, this is almost always imaginary. Okay. And so clearly we cannot say that a complex number is not, sorry, this is almost always complex, not imaginary. So we cannot say that a real number is equal to a complex number. Obviously, it is not possible. So a signal and a phasor are not same. Okay. A signal, you can see it in your CRO. A phasor, you cannot see in that. Yet, we often prefer to represent any signal as a phasor because it gives us some advantages. The most important probably is that it makes our calculations much easier. How it makes our calculation much easier? Suppose I have a phasor V, that is Vm root 2 e to the power of I omega t plus phi. What is dV by dt? What is dV by dt?
Vm by root 2 into
Pm by root 2, then
into omega I omega
very good, then
into e to the power I omega t plus phi.
very good, well done. All of you agree?
Yes,
All
sir.
of you agree? Now see the brilliance in this. Can I write it in this way? Can I write it in this way? Is it okay to write it in this way? Yes or no? Is it okay to write it in this way? I omega times V.
Yes, sir.
Right? Now see, if we had taken the original form, Vt equal to Vm Vt cos omega t plus phi naught. What would have been dVt by dt? Vm omega sine of omega t plus phi, that is not equal to omega times Vt. Right? Right?
Minus.
Why minus? Okay, fine. Minus. Okay, agree. Still not equal? Because here is cos, here is sine. We cannot have this freedom to write this with normal signals. Okay. Can we get this signal back? What is the correct answer was this? Can we get this correct answer back? What is the real part of this? What is real part of dvt by dt. That is Vm by root 2 real part of I omega e to the power of I omega t plus phi. Correct? Okay. Now
Yes, sir.
be very careful and see. Can we write this? Can we write this? Think carefully and let's see. Is it okay? We can write this. Because what is this? E to the power of it was e to the power of I pi by 2. That is cos of pi by 2 plus I sine of, sorry, not omega. I but this not omega. Sine of pi by 2. This is 0 plus I into 1. That is I. So this can be written as Vm by root 2 real part of omega e to the power of I pi by 2 e to the power of I omega t plus phi. So I can write it as Vm by root 2